Pause the video to have a go at the question. Okay, so we could look at this problem by just looking at the discriminant, which is to substitute in and rearrange. So if c is negative, then we get negative 4c is positive, and we already know square numbers are positive. So b squared minus 4c is definitely positive, which gives us distinct roots. Now the question becomes, could c be positive if the discriminant and the discriminant remain positive? So we could look around for numbers, and if I put in b is 5 and c is 1, I find that I can have a positive c and still have two roots. If we look at it graphically, as the question actually asks, and I figured out in the end I needed to do, if I have c is actually represented on the graph by the y-intercept, so I can see if c is negative, the graph is forced down below the x-axis twice. However, I can also see if I have a positive value for c, it's possible to get two roots. So c being negative is not necessary for two distinct roots to a quadratic. So what is necessary and sufficient? Well, we can just take that discriminant and say, well, b squared has to be greater than 4c. Okay, so we are going to return to the curve sketching idea, and we aren't going to be able to find the roots directly by solving the equation, but we can find the stationary points. So we set about, and also things to do with the gradient. So we know the shape of a cubic, and if it's coming down with a positive gradient where x is 0, it's cutting through the y-axis in this direction. So we have a limited number of curves we could have. I'm just drawing some on there now. And you can see the two potential stationary points that could be there. Could go above the curve and we see roots. So there's lots of different situations, and it's our job to find out what's going on. So we're going to find the stationary points of our equation. Now here, it's important to remember that p is positive. So if we try to take the square root at this point, we reach a problem. There are no roots. Now what does this mean? This means that the equation never has gradient of 0. So it's going to be kind of a bit like x cubed in that it never actually has a stationary point. Now that's good because it just gives us one positive root, and that we can see that graphically really nicely. Next, what if we make p negative instead? So all the working is the same, but p is negative. The graph changes. So our gradient is going to go through negatively. And we have two roots to the gradient function being equal to 0. So that means we have 2 points. You can see that they are positive and negative of the same number, and that the left one, the negative one, must be the maximum because of the shape of the graph. So what we're going to do is substitute those in to our function itself. And that, if that is positive, then we're going to have 2 extra roots that are negative. If it's equal to 0, we're going to have 1 equal root to go with our positive root that is negative. And finally, if it's less than 0, we have no extra roots to add to our single positive root. Now the algebra here gets quite tricky, and we're going to follow the route for the value of fx being greater than 0, and then at the end we can change it to an equal sign and flip the direction and find deduce the other two. Okay, so simplifying, we can multiply the root, big horrible square root of negative p over 3 by itself once to remove the square root, which explains this. Now notice we're dealing with the same roots, so when we subtract, it's a third, take away 1, which gives us negative 2/3. Now taking the p and the third and the negative together inside a bracket and raising it to the power 1 gives us the equation that you see, or the inequality that you see. Now we know that q is negative, so negative q must be positive. So these two numbers are both positive, we can square them. And now we have deduced that the value of the expression in the question is negative when there are 3 roots in total, with 2 being negative and 1 being positive. Now that's when the expression is negative. When the expression is equal to 0, that's when we have 1 single repeated root and a positive one to go with it. And finally, we don't get a negative root at all, we only have the positive root.